All right, so in the 2013 timeframe, the U.S. Coast Guard received reports of Texas flatboats end swapping. And unfortunately, one of these accidents had a fatality associated with it. Now, some important things to understand. What is end swapping? Really, you can kind of look at it as the sudden and unexpected rotation of a boat. Basically, you're losing directional control of the boat. You can think of it as a spin out, right? And then really, what's a flats boat? That's something that comes up. They're kind of unique boats. There's different styles of them, and in this case, these were deemed as Texas flats boats. And they kind of had a unique design to them. Obviously, they're intended for shallow water operation. They have kind of flat decks with little to no gunnels, right? So there's really not a lot of containment of the people that are on the boat. Um, these boats had a very unique hull form. The ones that were associated with this end swapping, it had kind of a deep V bow. Then that would transition about halfway back of the boat to kind of a flat section that would then transition into a tunnel after the boat. So it's a really unique hull form, something you don't see every day. There's other flats boats out there that have much flatter bows with that. Another thing about these boats is they'd always have jack plates, right? So they're intended for shallow water operation. So they'd have a jack plate so you could run the engine up and down. And a lot of times the engine would have a very large, oversized anti-ventilation plate on that. So, um, really, after this accident, the Coast Guard was really, came to their forefront. They brought in a company that specialized in forensic engineering and accident reconstruction. They talked to ABYC as well to get some perspective. They had two of these boats that they were able to get, exemplar boats from the fatality uh, to test and look at. What they did with the hulls, the first thing was kind of a naval architectural analysis of the boats. They scanned the boat, they weighed the boat, they determined the center of gravity, really to kind of get an understanding of what's going on with the boat. Then the next step was, no one was too excited to jump on these boats and go out on the water. So we rigged the boats with remote controls. So they're remotely operated. We put a data acquisition system on there. We basically had film in place to document these boats so you can kind of see what's going on. And then we ran the boats through a series of 19 performance tests that were identified, starting from very slow, just turning the boat very slow to port, to starboard, slowly building up speeds. We'd do a lot of varied variables in these, right? We'd vary boat speed, engine trim, engine height, the degree of the turn, right? Is it a easy turn? Is it a hard turn? We also varied the weight of passengers and gear where it was on the boat. Was there more weight forward in the boat? Was there more just a single operator at the helm station with these boats there? So we'd kind of do all these tests, these two exemplar boats to really understand what was going on with them. And kind of some of the things that came out of is we understood that about 25 miles an hour and greater, you kind of do what we'd call a harder turn, which really wasn't that hard. And you'd end up with end swapping. Again, the boat would suddenly kind of rapidly spin out, um, come to an abrupt stop. There'd be kind of, high G forces um, on the passengers if they were kind of towards the ends of the boat as it spun. The center of gravity was actually pretty close to the operator location, which was kind of interesting. So the operator didn't experience quite the high G forces that, say, the passenger that was forward of the center console would experience there. So, we'd see that ejections were very possible, right? And this lined up with what the accident cases were, the reports were about this, sudden turn and ejections and instability on the boat. So, the analysis, now that we understood what caused it or what, when it would happen, next is kind of the why, what was going on with the boat. And what you'd see is this tunnel, it'd be providing water to the outboard when you're going straight forward. But as you turned, the outboard would slowly start to come out of the flow of water and would lose its ability to provide any kind of lateral stability of the boat. And as a result, the deep bow would dig in during the turn, and then the back of the boat, the stern of the boat would kind of lose its ability to provide any stability, and you'd spin around, you'd end swap. So that was the understood mechanism of why these boats would do this. So that also makes sense on why boats that don't have this deep V in the bow wouldn't exhibit this. They would tend to slide more than to dig in. That V would really dig into the water there. So one of the things that was identified was that, there's an immediate need to provide a warning on these boats about making turns above 25 miles an hour. And that was put out there with that. That was one of the outcomes of the initial analysis. So the second step to all this was really how do manufacturers identify this problem? How do you create a consistent way to identify it, to test it, make sure to get repeatable results? And again, we looked at a variety of options, tests that are already out there, whether it be the line avoidance test, the quick turn test, creating some new protocol. And we went and took some boats and we kind of ran them through some of those protocols out there. And we were able to identify that the quick turn test from ABYC H26 powering in boats was valid. It worked. It identified the end swapping characteristics. It's currently used by a lot of manufacturers, but I don't think these manufacturers necessarily tested the boat. And typically, any boat that exceeds 30 miles an hour is supposed to do this test per ABYC H26. So this test, quick turn test, made sense, is valid. It identified the problem. So then with that, now we had a means to consistently identify this and test it. The question was, could this problem be engineered out, right? And we weren't going to look at every single possibility, but based on this understanding that the engine comes out of the flow of water, it's losing its lateral stability on the boat. Is there a way to add more lateral stability to the boat while turning? So we had an engineering firm come up with proposals, and the first one was to add 72-inch long skegs that are about 4.5 inches tall on the bottom of the boat. And they were basically from the center line to the chines, about halfway between those two. And the goal was not to increase the draft of the boat. I mean, these boats are intended to run through very shallow water, so we didn't want to increase the draft of the boat. We didn't want to significantly decrease the speed of the boat, because that's obviously an operational characteristic of that. But we did want to improve the handling and reduce the potential for end swapping. So that was the first one, basically a 6-foot long skeg mounted in the aft third of the boat, halfway between the center line and the chine. And that one did successfully reduce the instability. It passed the quick turn test. It did reduce the top speed of the boat by a couple miles an hour. Makes sense. You are increasing the drag, the surface area on that, but it did kind of what we intended. It reduced that instability and couldn't get the boat to end swap. The second one was a much smaller skeg. It's about 18 inches long and it was only 4 inches tall. We put that just forward of the transom also, again, halfway between the center line and the chine. And this also reduced some of that instability, and that boat was able to pass the quick turn test, but the operator during it, you could feel it, right? When you're operating these boats, you can feel the steering gets very light. There's basically there's no feedback in there. So the operator basically said, yeah, it's right on the edge. There's definitely some degradation in the controls that could result in end swapping there, losing that lateral stability. So while it passed, it's not a great solution, but it basically says that there is a engineering solution out there to eliminate this problem that manufacturers could pursue. We obviously didn't modify the bow area, kind of V of the boat in the bow that kind of exceeded what we intended to set out. That would have been very a major change to the boat. So we didn't do that. But really, the goal was to provide some insight into, what's causing this issue and how to solve it. And we were able to do that. From a safety campaign side, the results were published in the Boating Safety Circular, so that went out to the general public, to the boating industry at large. We also held a webinar for targeting manufacturers to really explain what the issue was, what the cause was, and what potential solutions might be. Had a test for this as well, with the ABYC H26 quick turn test, without, so that was made available as well. And I know the Coast Guard conducted some direct outreach to manufacturers as well on that.